Hello, and welcome back to the video lecture series for the Introduction to the Art of Programming using Scala. We're moving close to the end of the chapter on recursion, and this particular video happens to deal with a new construct. It's called match. Like the if statement, it can be used as both a statement and an expression, and we will see how we can use it in both ways. The match is also like the if in the sense that it is conditional, and this is why it makes sense to put it in the chapter on recursion, is that because it is conditional, it gives us another way of setting up our recursive functions. So why would you use match instead of if? Well, the match statement is in some ways like a much more powerful if that can have multiple branches in it. And we're only going to begin to see some of the power right now. What we're going to see first is just the fact that we can put in multiple branches. So we'll bring up the REPL, and I am going to write a little function called GPA, and it is going to take a grade, which is a char. And it's going to return an int. Now what I'm doing here is I'm writing a function that takes a letter grade, A, B, C, D, F, and returns the GPA equivalent using kind of a standard scheme where A is a 4, B is a 3, etc. Now, we could have done this with ifs. We could have said if grade equals blank, do something. If grade equals blank, do something. If grade equals blank, do something. The idea of the match is that it is more succinct. So the syntax is first you give the expression you want to match on. Now in this case our expression is a simple variable name, grade. And then the keyword match, and then a set of curly braces. And inside of here we give it a number of cases. Now the way I've written this here, I am using it as an expression. I just put it in there and I'm expecting it to give me back a value as opposed to mutating something. Actually, let's go ahead and let's do that. Let's say I want to use it as a statement first. Well, just like with the if as a statement, this generally means I set up a var, which is the, I'll call it points, and it'll start off as 0. And then I will do my match. And inside of here I have cases. So what's one case? Well, your grade could be an A. You give case, and then you give, technically this is a pattern, and we'll see what it means to be a pattern a little bit later. Here I'm giving it the simplest form of pattern, which is just a literal value. Okay, so this is a case that only matches for A, and if we have an A, I want to set points equal to 4. So remember, I'm doing this as a statement, so it is doing mutations. Similarly, in the case of a B, I want points equal to 3. In the case of a C, I want points set equal to 2. In the case of a D, I want points equal to 1. Now I could put in the case of F here, or I could match anything that I want. So if you don't have an A, B, C, or D, we're going to give you 0 points for that. And one way to match that is to use the underscore. Just like we saw how we could use an underscore in our function literals earlier, and it kind of stands for something. Well, this is the case of something, anything, we don't matter. Whatever else, it will do this. So the way that, I'll go ahead and finish off the function. The way that the match works is it runs from one case to the next, to the next, to the next, and the first thing that matches, it does that. In the case of a statement, if we're using it as a statement as we are here, it will do that thing. So if I call GPA on A, I get back 4. If I call it on B, I get back 3, etc. Okay, so our GPA function works nicely. That's using match as a statement where it is mutating things and it is causing changes. It has side effects to it. A lot of times it's better to use it as an expression, so it gives you back a value. So I'm going to call this GPA 2, and it's also going to take a grade, which is a char, and it's going to return an int. Now, in this case, there's only going to be one expression inside of this function, and that one expression is the match. Kind of as a general style rule, if the only thing inside of a function is a match, you will often put that match up at the top. So I will just say it's equal to grade match and then have the curly braces for all the cases inside of the match. You don't have to do this. I could have had another set of curly braces here, and then I could have closed off those curly braces at the end. But in some ways the logic is why? Why bother putting in those extra curly braces if they're not really needed? Your function can have any expression after it. Remember that the curly braces, it just defines a block of code, which is a large expression that has a value equal to the last thing inside of it. And so inside of here, I would have, again, my case for A. Now in this case, though, I'm not using this as a statement. I'm just using it as an expression. So I don't want to do any mutation. I don't have a variable called points here. I just want to say 4. If it was A, give back 4. If it was B, give back 3. If it was C, give back 2. If it was D, give back 1. In all other cases, give back 0. I close that off, and we get this. So once again, just like we saw with the if, using this as an expression instead of a statement often makes the code more compact. And this happens to be one of those examples where we get a more compact usage from using it as an expression. So this was one example of a match, and here you can see we have 5 different cases. So you can see how in some ways this is, we're utilizing the fact that match has multiple options in it. Yeah, well, I want to write a somewhat different version. We wrote factorial previously. I want to edit our factorial so that it uses a match. Okay. And now this isn't necessarily an instance where the match is necessarily ideal. It might wind up being a little longer, in fact, here. But it's nice to show how it would work. So in this case, if you get down to a 0, the factorial of 0 happens to be 1. That actually is the mathematical definition. I'm actually going to put in another case for 1, which is also 1. Case anything else is going to return that. And I will call this factorial m for match. And we can print out, make sure that we've typed this in properly. Oh, the case, yes. It's saying that the 0 can't match a big int. Technically, I can fix this by saying, okay, well, then I want the big int of 0 and the big int of 1. Oh, those aren't going to work on patterns, and we haven't talked about patterns. So how can I get around this? Actually, this is a very good introduction of something. I am going to define 2 things called 0 and 1. I'm going to define them out here. Val 0 equals big int of 0, 1 equals big int of 1. as I mentioned earlier, the factorial isn't necessarily the best option for doing this, but I do think it's helpful for you to see what it does, and we do get 120 out of this. Now, what I have typed in here should have given you all types of questions. Okay, the first, why did it not work with what I had before? And you might also wonder, why did I make it so that 0 and 1 start with capital letters? That should be a major question on your mind. And it turns out the reason is due to the fact that this right here is technically not just does not have to be just a literal value. If you've learned how to program in another language, for example C or Java or C++, you might be familiar with their switch statements, and match in some ways looks a lot like a switch, but it turns out match is far more powerful than switch. And one of the limitations of switch is that you just get to put in a literal value here. And that's not what happens inside of a match. A match actually gets to do something called a pattern. Now, we've mentioned patterns before, and I want to show you kind of how patterns can come up. We'll pull up the REPL here. And the first, so we've actually done this in the case of, let's see, val t equals 3 comma high. Okay. So the second way that we learned how to pull values out of a tuple was by making a val or a var. And I mentioned briefly the fact that what's over here is technically a pattern. And so this, Scala looks at this and says, oh, well, this is a tuple, and so it will only work if this is a tuple. And what I want to do is I want to pull the first value of the tuple and make it the variable age, and the second one and make it the variable word. Okay. And technically, this was a pattern, but it was a pattern that just had the name t here. So the first question to ask is, why the uppercase? Well, let's see what happens if I do the same thing here, but I change age to a capital A. I get a very different behavior. Instead of creating a variable called age and giving it the value 3, I get an error that says that Scala couldn't find the value age. Well, I haven't defined an age, so in some ways that makes sense, but why was it that this created a new variable for us and this said that the name wasn't found? Turns out the answer to that is that in patterns, any word that starts with a lowercase letter, like age, or word with a lowercase w, is assumed to be a variable name, and you're supposed to take the proper parts out of the pattern and stick them into those variables. However, if it starts with an uppercase letter, then it is assumed to be a value that has been defined someplace, for example, 0 or 1. If I had used the lowercase z here, let's see if Scala is actually happy allowing me to do that. Turns out it makes some parts of the code unreachable. Scala, yeah. So it says unreachable code in here. And you might wonder, what does that mean? Well, it turns out that because this 0 starts with lowercase z, it matches anything. It says, oh, you're a variable name. I'm just going to take whatever value n is and stick it in the name 0. But that means that this case, because it matches everything, it's impossible to get to these two cases. So we get the unreachable code error. Okay, so that explains why capital letters versus lowercase letters and why we had to do that here. It also shows you how in a pattern these things wind up creating variables and they can be bound even short term. So for example, instead of doing an underscore here, if I had done a lowercase m, turns out that m would have been bound to whatever was here, which happens to be n, and this function will continue to work just the same. Okay. Because in some ways with this, m becomes another name for n. I already had a name for n, so that was why originally I used the underscore instead. Okay. in order to demonstrate the use of patterns, I kind of need to show you one more thing about Scala and Scala's type system that hasn't appeared in these videos previously. And it's possible, depending upon how much you've been playing with Scala, that you have seen this previously. So let's go with an if. If 5 is less than 3. Of course, 5 is not less than 3, so this is going to take on whatever the second value is. And for the first one, I say 99, else, other than my capitalization here, it's interesting to ask the question, what's odd, weird, unusual about this? Okay. If I had said 100, well, clearly this has the value of 100, and it's an int. What about this? Well, 5 is still not greater than 3. 5 is still not less than 3, so it will still be this, but there is a difference. This is a string, but the value that we get back doesn't have type string. Now, it would have if this had been a string. The thing about an if, and it turns out for a match as well, when they are being used as expressions, they are giving you back values, the type has to be a type that works for, in the case of an if, both branches of it. In the case of a match, all the branches of it. So every possible case in a match, you have to kind of have, in some ways, the same type, and Scala will figure that out for you. Now here, int and string are not the same type. Now this isn't actually an error in Scala. Instead, it uses a type that could be an int or it could be a string, and it's a type called any. And as the name implies, any represents any type. So every value in Scala is of type any, and so anything that you want can have this type. Now, why is that potentially significant? Well, let's let's do it here. No, we'll do it match.scala def match something. Okay, horribly named function. Generally, your functions should have a highly descriptive name. I am just writing some code here to be illustrative of a possible way that we could use the match, and in fact, a way that we kind of will use a match later on. And I'm going to pass in some argument. Okay. The thing about this argument is I'm not going to be specific about what type it is. I'm not going to say it's an int or a string or a double, or even, that should have been double, or even a tuple of int double. All I'm going to say is this can be any. Okay. I want it to be anything that you pass in, and I'm just going to have this function print stuff for us as opposed to giving stuff back. And so what goes inside of here, if I can type that properly? Well, let's write some different cases. Okay. Because this is pattern matching, and because arg can be an any, well, so obviously it could be, a simple integer. And then I'll print line. Okay. Maybe it's a string. But those are just giving you simple literals. Let's do some pattern things here. One pattern that we've seen is a tuple. Now, when I make the pattern of a tuple of A and B, remember A and B, because they are lowercase letters, are going to be bound as variable names. So inside of this, actually, let's go ahead and, just to make it clear, in the cases, I can have multiple lines. And I haven't been doing that but I can. Once again, if you are used to switch in other languages, switch does a fall through, the case does not. So when it executes, if it does match mark, it will print this out, and that's it. It's done. Okay, so that's a case that will match any two tuple. So any two things, and then it will print out their values because A and B are bound as variables to the things inside of that. And this is significant because it turns out that other than using this pattern match here, you would have had a hard time pulling out the two pieces of arg because Scala doesn't know at this point that arg is a tuple. It knows that it's an any. There are some other things that you can do with patterns. So you can, kind of in the standard type of notation you're used to in Scala, put a colon and a type. And so I can specify, well, this is a case where I'm going to create a variable x under the condition that whatever I'm matching is a double. So if arg happens to be a double, this case will match it. If it's anything that's not a double, it will keep on going to the next thing. What if they give you some integer that happens to not be 42? Well, if it's not 42, this won't catch it. This will catch any int and give it the name I. In this case, I'm not going to tell you what it was. I just cared that it was an int. We'll just have one more case, the underscore. Okay. It didn't match any of our other things, so we hit there. And we can come over here into the REPL, and we can load in that file. And let's try this. So, hi. That wasn't one of our cases. Mark was 42. 3 and 4. Okay, so there you can see how these patterns, some of the power that's in them, we will continue to see more options for patterns, different things you can do in addition to specifying a type and doing things like tuples. There are additional capabilities here, and you've also seen how the match can give you multiple different cases. The book goes into the fact that these cases can also have if guards on them. I'm not going to go into that here. This video is long enough. You can look at it. It's in the book. It's fairly straightforward. So that's it for the match. It's just another form of conditional statement that you can use that happens to be very powerful and lets us do some fun things inside of Scala.